In this video, we're going to talk about how you actually calculate inverse square law fields. We'll use an electric field as an example, but the same procedure would apply for gravitational fields or radiation fields. So let's say we have a charge Q at some position, which is x1, y1, z1 coordinates, and we want to work out what the field is at some different position, which has coordinates x2, y2 and z2. Now we know the equation for the electric field is that electric field equals a constant, which in this case is Q over 4 pi epsilon naught, 1 over mod r squared r hat. Now what is r? R is this vector here. So our first step is to work out r. So r is the difference from the final position to the new position. So that equals x2 minus x1, y2 minus y1, z2 minus z1. We can now ask what the length of r is, and that you get by Pythagoras. So it's the square root of each of these differences squared. So that tells us the bottom here. What is r hat? Well, there's a trick for that. Now, r hat, the unit vector up here, is the same as r divided by mod r. That's by definition because it's the same direction as r but at length 1. So if you divide the vector r by the length of r, you end up with something pointing the same way but of length 1. So what that tells us is we now know mod r, we know r, and we can rewrite this equation as E, electric vector, equals constant Q over 4 pi epsilon naught 1 over r cubed r vector, not r hat. So what we've done is we've simply substituted this into here, which gives us the r cubed at the bottom rather than r squared, the magnitude cubed, but we now have the full vector at the top rather than the unit vector. So we know what that is from up here. We know what this is from up there. So it's all solved.